Hello everyone. So in today's video of chapter elements of group 1 and group 2, I am going to talk about diagonal relationship and some compounds of group 1. Let's start. Diagonal relationship. It is expected to every element present in a particular group that its properties should be belonging to all other group elements and used to show the gradation in their properties, the similarity and gradation in their properties. But the first alkali metal, lithium, and the first alkaline earth metal, beryllium, do not fulfill this expectation. Lithium shows many differences when we compare lithium with other alkali metals, and it used to show similarity with magnesium present in group 2. Similarly, beryllium shows many differences when we used to compare its property with other alkaline earth metals present in group 2 and shows similarity with aluminium present in group 13. The relative placement of these elements with similar properties in the periodic table appears to be across a diagonal, and this is called diagonal relationship. If you see here, lithium is showing similarity to magnesium, which is diagonally present to lithium. Beryllium is showing similarity like aluminium, which is present diagonally to beryllium. So such kind of relationship is called diagonal relationship. Diagonal relationship between the elemental pairs belonging to different groups and period is due to the similarity in some of their atomic properties. The atomic radii, ionic radii of lithium and magnesium are quite similar. In the case of beryllium and aluminium, the charge to radius ratio of their ions is very similar. Now, let's see the resemblance in between the lithium and magnesium. If lithium is burnt in air, we used to get lithium oxide and lithium nitride. When magnesium is burnt in air, we will get magnesium oxide and magnesium nitride. Both are showing the same characteristics, the same chemical property. When we are decomposing lithium carbonate, we are getting lithium oxide and carbon dioxide. When we are decomposing magnesium carbonate or magnesium bicarbonate, we are getting this oxide and carbon dioxide. Now let's see group 1 elements, the other elements other than lithium. When they are reacting with air, they will give you oxide or peroxide or superoxide also. But group 2 elements, other group 2 elements, they used to give you nitride and oxide. Here, if the carbonates of alkali metals are taken other than lithium, they will not decompose. But the other group elements of alkaline earth metals, they will decompose to give you oxide and carbon dioxide. The chlorides of lithium and magnesium both are deliquescent. Other alkali metals chloride are not deliquescent. Group 2 elements chloride are deliquescent. Whereas if you see, all alkaline earth metals chloride are hydrated salts. Whereas lithium chloride is also hydrated. Whereas group 1 chlorides except lithium are not hydrated. So this is the resemblance between the lithium and magnesium. If we talk about beryllium and aluminium, this is the nature of bonding in case of beryllium. Chain structure with chlorine bridges. Similar structures to aluminium chloride we are seeing, the bridges. BeCl2 is Lewis acid. AlCl3 is also Lewis acid. Beryllium chloride and aluminium chloride both are acting as Lewis acid. They are soluble in the organic solvents. And beryllium oxide and aluminium oxide both are amphoteric. That means they used to show reaction with acids as well as with base. If we talk about group 2 elements and group 13 elements, group 2 elements used to form ionic compounds. Group 13 used to form covalent compounds. Group 2 elements, does not act as Lewis acid. 13 elements used to act as Lewis acid. They are not soluble in organic solvent because they used to form ionic compounds. Since group 13 elements are forming covalent compounds, that is why they are soluble in organic solvents. And if we talk about the group 2 element used to have a basic nature. That is why they react with acid to give salt and hydrogen gas. They would not react with any alkali like NaOH. Group 13 oxide are generally amphoteric. So this is the similarity between beryllium and aluminium. Now, what all are the uses of elements of group 1 and group 2? Lithium metal is used in lifelong batteries, in digital watches, calculators, computers. You must have listened this. Liquid sodium is used for heat transfer in nuclear power station. Potassium salts are used as the fertilizer. Potassium is used in manufacturing of potassium superoxide for oxygen generator, and it is also a good absorbent of carbon dioxide. And very important, cesium is used in photoelectric cells. If we talk about group 2 elements, beryllium is used as moderator in nuclear reactors. Alloy of magnesium and aluminium is widely used as the structural material in aircrafts. Calcium ions are important ingredient in biological system, essential for hair, healthy growth and bones and teeth. And barium sulfate is used as medicine in medicines as barium meal for intestinal X-ray. Now, the first compound is NaOH. NaOH is also called as caustic soda. Sodium hydroxide is commercially obtained by the electrolysis of sodium chloride. Sodium chloride is dissolved in water, and one saturated solution is prepared, which is called as brine solution, and this saturated solution is used to be electrolyzed in a cell called Castner-Kellner cell. Mercury is used as cathode and carbon is used as anode. Metallic sodium liberated at cathode, it used to form sodium amalgam. So we can say sodium amalgam is forming at cathode when it is accepting one electron to form sodium amalgam, and on anode what will happen? Chloride ion will lose electron to give you chlorine gas. Sodium hydroxide is obtained by treating sodium amalgam with water when hydrogen gas is liberated. This is sodium amalgam. When it is treated with water, it will give you sodium hydroxide. Silver is removed and hydrogen gas is liberated. Now, properties of sodium hydroxide. Sodium hydroxide is white deliquescent solid. It is having melting point 591 Kelvin. It is highly soluble in water and used to form strong alkali. The surface of solution absorb atmospheric carbon dioxide to give you sodium carbonate. Now, what are the uses of NaOH? NaOH is used in purification of bauxite, the aluminium ore. It is used in commercial production of soap, paper, artificial silk and many chemicals. It is used for mercerizing of cotton fabrics. It is used in petroleum refining, and it is used as a popular laboratory reagent. Now, another compound, lithium aluminium hydride, LiAlH4. Lithium aluminium hydride is commonly abbreviated as LAH. Its chemical formula is LiAlH4, and it is prepared by treating lithium hydride with aluminium chloride. Lithium aluminium hydride will form along with lithium chloride. Properties: lithium aluminium hydride is colorless solid. It reacts violently with water and even with atmospheric moisture also. If I talk about uses, lithium aluminium hydride is a source of hydride and therefore it is used as reducing agent. If you see the reaction on the screen, it is one ester. When I want to reduce it, with the help of lithium aluminium hydride, it will give me alcohol. For example, if I am taking any acid, it will give me alcohol and water if it is reduced with the help of LaH or lithium aluminium hydride. Both the reaction used to happen in dry ether solution. Another use of LaH is to prepare phosphine gas. Phosphine formula is PH3, and if PCl3 is reacting with lithium aluminium hydride, it produces phosphine gas along with aluminium chloride and lithium chloride. So this is the uses of lithium aluminium hydride.